song. What's up, y'all? Thanks for joining. I'm going to do some Leetcode. It's past 11 p.m. where I'm at, so yes, I'm tired. Got some 7-Eleven coffee. It's like a medium or a large. I think it's a medium, right? Their larges are like bigger than this, right? But 6 pumps of hazelnut. I had the Monster energy drink, cookies and cream with protein coffee. It was all right, but anyway, we got some caffeine going. Should be sleepy naturally. Got some caffeine going. We're gonna try to compensate. This is the famous blind 75. And so even though I'm tired, in theory, right up top, these are easies. So let's jump in there. I have no idea if I'm gonna be able to do this in 10 minutes or if it's gonna take me an hour. I have no idea. So let's jump in. If you're on TikTok, thanks for being here. Probably going to be easier for you to see this on YouTube or Twitch, where you can see the whole screen really nicely and see my sleep-deprived, baggy-eyed face. So handle is just John Vandeveer, same as my TikTok handle. And you can find me on Twitter and YouTube. I'm not sure if that's my Twitch handle. Let me double check real quick. Hold on. Go to Twitter or YouTube. Don't go to my Twitch. Like, my Twitch is really inconsistent. So, but it's also John Vandeveer if you want to pick that one for some reason. All right, cool. Let's dive in. To-sum. I think I know the to-sum. Let's do this one. Actually, I'm going to open this in a new tab. I want the... oh, and I need to sign in. But I want the blind 75 tab to remain open. So this is, yeah, it has my history from months ago, right? Okay, so it knows who I am. Refresh this page. Let's get that to-sum, y'all. Okay, given an array of integer nums and integer target, return indices of the two numbers such that they add up to target. Cool. I'm going to come over here and start with some comments, and I'm going to talk about some edge cases, like what if nums is empty or one value. Actually, I know what to do. It says return indices the two numbers. Yeah, I'll just write that out. It may never be empty or one value. What if no combo adds to target? Okay, cool. And then kind of naive strategy, and it may be the optimal strategy. So I distinguish between, so I'm going to say not necessarily brute force. So I distinguish between the naive strategy and the brute force strategy. The naive strategy is just the one that comes to the top of my head. Hello, Edward Cam, thanks for joining. So naive strategy is just what comes to the top of my head. It may or may not be brute force. It may or may not be optimal. So I'm distinguishing between those two. The one that's naive to me is to do the difference. So, for example, what if target is in nums? Then I need to find 0. If target in nums, find 0. And so I would say, more generally, for k in nums, check if nums includes, and technically we'd want to do nums minus index of k, right? So like we can't, if the target is 10 and k is 5, we can't just find 5 twice. It would have to be a different index. That's my point. More generally, for k and nums, check if nums minus index of k includes target minus k. Does that make sense? It's like a really complicated way of saying if target in nums find 0 is the kind of like more intuitive thing. Is this Python? I'm not writing in Python. Hit me up some other stream. I'll do it in Python if you want. Dark mode is greater than light mode. Yeah, agree. I mean, I don't care, but I agree. Okay, where's that fucking button to change the mode? Hey, you tell me where the button is, I'll click it, but I'm not trying to get distracted on stuff that doesn't matter. Okay, So next thing I want to do, let's run through a couple examples, but those are basically my pseudocode and my naive strategy. Example 1, nums 2, 7, 11, 15, target is 9. So here we have 2. My naive strategy would be 9 minus 2 equals 7. Does nums include 7? The answer is yes. And then, yeah, so they clarify that not only do we return like true, like the Boolean, we actually want the indices. So I'll specify return indices, or like index pair of interest. Cool. Sister 19101 online. Cool, I think. I don't know what that means. Thanks for tuning in, though. Glad to see ya. Okay. Index 2, 3, 2, 4. We got 6, so I got 3. And so I'm going to be looking for 3, but it can't be the same 3. We want a different index, right? And so the answer would be like, nah. There's no other 3. So we're going to proceed. Now we're at 2. Now I want to see 4. Okay, and there it is. So that's how we get the successful answer. And then, yeah, there's the edge case where it's 3, but you can't repeat the same index. I want to see the constraints. Yeah, so they guarantee I'm never going to have to check. So the answer is don't worry about it. Never will happen. Okay, so we're constrained that will never be a problem. All right, so let's go ahead and move on to the implementation here. I want to do for const num and nums. It'll be of nums, sorry. But I also want the index. So I'm going to say const idx in nums. And we can switch this over to a like classic iterated for loop if I need to, but I'm going to try to do the in operator here. And then, so I'll put it to do, just like to catch myself in case there's an issue. If in operator is abused, switch to classic, let I equal 0, etc., etc. Okay. So we'll fall back to that if we need to. And then eventually we are going to return, I'm going to call this index pair of interest. So it's literally this long variable name, but I will go long and descriptive over short and uninformative every time. Okay, so we are going to initialize that to an empty array. So when did you get good in Leetcode? I don't know if I'm good. I mean, I can crush easies and like I can get mediums, but you throw me a hard one and you're going to be like, yo, this guy didn't get good. Sometimes it's like a 50-50 shot if you throw me a hard. Anyway, Leetcode and Algo Expert, just practice them. And also just code projects too. Just get good with the language itself. I think overall it takes like a year or two. I don't know. For me, depends on the person, I guess. Okay, so index pair of interest. So const idx of nums, and then we'll have const cur num equals nums idx, right? So there's cur num. For const like ijk. When you nest iterations, ijk is common. I'd really rather not nest here. Before I nest, okay, so I'll do a to-do nest only if I have to. What I'd rather do is I can do a single pass and get differences. Like target, I'm going to call this target deltas. And so what target deltas is, it's the array of these, like say that I get the 2, the value here would be 4. That's the target delta. And I'm just going to have an array of those. So that's a single pass. So then we can solve 2sum in a double pass, but I think a double pass is still it's still O of n time, which is like way better than n squared, right? I'm so mid with Leetcode. I don't know how I passed my technical. Hey, that's cool. I mean, you made it. You made it. Haven't looked at Leetcode in a long time. I wish I could say the same. Okay. So second pass strategy is a 2-pass solution. Second pass and 2-pass, those are actually like 2 different things. Second pass strategy is like as opposed to the naive solution. Where did I say? Naive strategy, if target nums, find 0, more generally, right? So it's kind of like refining that, because this naive strategy you could implement 2 ways, either an O of n squared or an O of 2n. So we're going to go O of 2n, which of course reduces to O of n. Cool. So let me compute. So first we're going to get target deltas. I'm going to say target deltas equals get target deltas. We're going to pass target. We're going to pass nums. Let's do nums target just for consistency. Nums target. Okay, so get target deltas is a helper function. Put it up top. Equals nums target. And this is target dot map. No, nums.map, sorry. Goes to nums.map of num goes to math.absolute value. Is it ABS? Let's do it like this. Num is greater than target question mark. We'll do a ternary approach. If num is greater, then we return num minus target. Else return target minus num. And this is equivalent to an absolute value expression. I just can't remember if it's math.abs or if it's something else. So like if the interviewer was cool, I would just double check it. I'm pretty sure it's math.abs. But this way is kind of like fail-safe. So if the number is greater than the target, you're going to get a positive here. Otherwise, you're going to get at least non-negative there. It could be a 0. So get target deltas. Now I have my target deltas. I can actually take this up here. Right, so just initialize it to the final value. Target deltas. Now what I want to do, yeah, now I can just do this in a single pass. So for the index and numbers, there's the current number and there's the current delta. Current delta. Nope, this is not going to work again. This is not going to work again. Dang. Third pass strategy is maybe sort deltas. But like this is like something I shouldn't have to do. So, oh, math.abs. Yeah, I thought so. Is this O of n? It should be. It should be. But I don't think I should have to. Yeah, so I get the deltas. For each delta, I have to check. Ooh, no, I need to turn it into a map. So I could sort, but it would actually be slower. That would be n log n. But that would actually be slower than a map. Fourth pass strategy is use a map for deltas. Okay, so this is going to be optimal. This is going to be O of n. So target deltas is still correct, but it should return a map, not an array. Cool, so let's redefine our helper function. So we'll make a constant called delta map. This is a hash map or an object, and we'll eventually return it. And in fact, you can do this in a single pass. So that will be a fifth pass strategy. Is you can construct delta map on the fly for a single pass. So fourth and fifth pass strategies are both going to be O of n, but the fifth pass will be a single pass O of n instead of an O of 2n. Yes, JavaScript. I used to use Java when I was a beginner too. That won't run. You have an error in the code. Trust me, I know. This code is not ready to run. Like, thanks for the backseat driving. Okay, so I don't even want to do this helper anymore because I know that I can construct it on the fly. Let's just go do that. So do I even want the index at this point? I don't even need to keep track of the index at this point. Okay, so I'm going to comment all this, but I still do want index pair of interest, but I'm going to bring it out here. So I'm going to say for const per num of nums, not in, of. So of is the value, in is the index, in is for index. And then I'll do const per delta equals target, or it'll be somebody cheated and gave me the thing, so I'll just use it. That'll be target minus per num. And then we're going to have a scene map. Call it scene. It's just a cache. It's just like a convention for a cache. So if you've seen it, use it. If you haven't seen it, store it. So cur delta is there. And so if scene, oh, we do need the indexes. That's what we need them for, right? I kind of forgot what we're doing. So the value of the scene map can be the index. All right, I lied. We need this after all. Cool. Ew, comment all that. So we're going to call this scene const scene equals if the in operator is abused, fine, and then you have the index. Here's the current num, here's the current delta. That will be math.abs target minus cur num. Okay, so that's the current delta, and that's only if I have to, and I don't have to. So we'll say if scene return IDX. I don't think it order matters, does it? I'm just now thinking of this question, but like, I'll just put it here. Does IDX order matter? Question mark. But I'll just assume that it's not, and then if we fail out, I can like sort it or something. So return the current index and then return the scene index. That would be scene cur delta. So scene is a map of indices of scene deltas. Okay. What are you coding? This is the solution to the two sum easy algorithm. Okay, so if we've seen it, there's an edge case here where this could be 0. So I don't want to just do this falsy check. I want to say if this is not undefined. So I can do type of. There's 2 ways that I can do this. One is I can do type of is not equal undefined. The other way is I can do if it exists and it's not, if it exists or if it's 0. I could also do that. I'll write that down. To do, could do if seen or. So that would be another way to do that, to get around this falsy trap edge case with a cached index of 0. Okay, great. So we'll return that. Otherwise, else, we will store it. So if you've seen it, use it. If you haven't seen it, you have now seen it, right? Otherwise, seen of the current delta is the current index. Okay, so I think at this point, I'm ready to test it. Let me do a glance through to make sure that nothing obvious is going wrong. Obviously, I can clean up this code. Index pair of interest. I don't need that defined twice. Let's get rid of all this. Right? If the for operator is abused, fine. Does order matter? We can run through our instructions. You can return the answer in any order. So then I can get rid of this question. We have clarified the answer is no. Or I'll just, yeah. So we'll get rid of the comment because we've clarified the answer is no. I don't know. I always go back and forth on this. It's kind of worth it to keep it to, like, if the interviewer is going to review notes after the fact, you can review the fact that you made note of this. Instructions say no. Clean up the helpers that I no longer need. All right, there's a slight indentation. 1, 2, 3, 4. Yeah, fine. Slight indentation off there, but that's fixed now. So it's cleaner now, right? So let's run it. Run code. Wrong answer. Cool. So what is wrong here? In the case, I returned 2, 1. They were expecting 0, 1. So it looks kind of like I have an index of 1 error. So let's run through an example, and maybe I can just like do a -1 somewhere and fix it. So const idx and nums. The debugger is locked. Maybe I should pay for it. I thought I had Leetcode Premium. I guess I got Premium turned off. What I would really do here is I would console.log idx, and I would make sure that idx starts at 0. I think that's all that's going on. So let's convert this. If in operator is abused, switch. It kind of looks like the in operator is being abused. So I'll do for let I equal 0. I is less than nums.length I plus plus. Okay. And so down here at the bottom, we will, yeah, no, we don't need to do that. We're already auto incrementing. Now we'll convert idx to I. Okay. So the fact that we're using this less than nums length, does this now, and we're starting with 0. Okay. Does this fix our issue? Let's run it. Still wrong. So I'm returning 2, 1, so I'm getting here. So let's work backwards from this return solution. So I is 2. When I is 2, 0, 1, 2, 0, 1, 2. We're on 11. So we're on a value of 11. And when I get to the value of 11, I'm falling into this case. How am I falling into this case? Because type of scene cur delta is not equal to undefined. I'm going to try the other if. Let's try this other if. I'm not really sure why this would be failing out, but so let's say it's greater than 0, or it's exactly equal to 0. I can just say greater than -1. I think that will work. Yeah, I would like to test this in like a console. I think I want to. I'm kind of picturing an interview. I don't know if they'd let me, but I just want to double check. So I'm going to go ahead and do it. So here I have the console, and I'm just double checking that foo, a string, or let's just double check undefined, is greater than -1. I want this to be false, and it's false. And I also want a string to be false, right? So it doesn't give me a type error. That's what I needed to verify. So confirm there's no type error, curve nums, math, target minus cur num. And so we confirm that's somehow type safe. There's like some kind of coercion going on. Yeah. Love you. Night. Okay, cool. All right, so this is still wrong. Line 33 above line 26. Let's take a look. Line 33. Line 33 above line 26. You should be exiting the loop a whole index earlier. That's really not obvious to me. How would I exit the loop before I? If I, okay, cur delta. Let's see, the cur delta. If we have seen the current delta, let's see. Hey, Leetcode, what's up, Mohi? So here's the current number. This would be like 3. In example 2, this would be like the value of 2. Has an index of 1, so the index is 1. And then the current delta would be 6 minus 2, so this is a value of 4. Have we seen 4? No, we've not seen 4. So now we're going to store that I have seen 4. Oh, this is wrong. We shouldn't store the current delta. We should store the current number. Yep, okay, that was it. A plus B is target. So let's say cur_num is A. So delta B is target minus A, not math absolute. No, you need the, Mohi, you need the absolute value. Hold on. Target minus A, not math absolute. Can I get a negative? Should work either way, right? Like 6 what is my target? If my target is less than my current value, then I need a negative. Yeah, I buy it. I do. If my target is less than my current, then I need a negative value. Yeah, I buy it. You're right. You're right, dog. Good catch. Now I feel like I cheated, but okay, I'll take it. I'll take the dub. Okay. Clean this up. I don't think that wrecked me. I think we're still good. Okay, ready to submit? I think we're ready to submit. You can put a dub in the chat. I know we already got one. Put another one if we're ready to submit, but I'm going to go ahead and go for it. Blam! Cool, yeah, so we passed. I don't know what's up with the yellow. I think this is just like Leetcode is suggesting related, kind of like related shit. Cool, I think we're good. I don't know why this is like faster than other people. It's just like a really basic implementation, yeah? Okay, cool. So let's go back to the blind and now let's see. I should have got like points for this or something, right? Whatever, I don't care. Oh, great, fucking stock. I fucking hate this shit. All right, let's do some stock. Green is easy. Yep. Oh, okay, okay. On those like related list or whatever. Gotcha, thanks. All right, y'all, this is the stock one. Here, I'll put the text. You're given an array of prices. Prices I is the price of given stock on the ith day. Maximize your profit choosing a single day in this case. And choosing a different day in the future to sell that stock. So maximum profit. Okay. So here, I'll just, like my intuition is that I need to sort this array, but let's hold our horses. So the price is buy on day 2, sell on day 5. Yeah. What if I had sorted this array? If I had sorted this array, I would say, hey, buy at 1, sell at 7. That's illegal. Then I could use a pointer maybe. I don't know about that. I might want to do a pointer pattern. I wouldn't waste my time coding a trading bot when Fang pays me to be busy. Does Fang pay good? Who's going to tell him? Who's going to tell him? Okay. I think I want to use a pattern. I think I want to use a pointer here. So 7, if I move, that feels like a bad move, but why? Wait, no, that's good, because we want to buy as low as possible. So let me jot down some notes from, this is like naive strategy. From left, buy as low as possible. And then from right, sell high. Okay, so that would be like, this would be like a pointer pattern. So naive pointer, right pointer moves left if if I minus 1 is higher, but left checks I plus 1 is lower. Or equal. I feel like if it's equal, why not? Depends on level, location, company, name. Thing pays a lot. I mean, you can say it depends, but like in general, it pays like a shitload of money. Okay, so let's test out our theory on this example, and then we'll check edge cases. So in this example, my rule is left pointer moves to the right if it's lower, and right pointer moves to the left if it is, right pointer moves to the left if it is higher. So my left pointer would move all the way, and my right pointer would move all the way in the opposite direction. That feels bad. So maybe keep a cache of current or like cur max profit and associated left and right pointers. Thanks for the likes, I appreciate that. So in this case, we would say left. Yeah, you never want to buy, never buy if left value is greater than right value. Right? So it'd be like never buy, never buy, never buy, never buy, and then you just never buy. Output 0, fine. Here, left is greater than right, so I buy. Then I check. Okay, hold on. Buy low, sell high. I think I might have said that backwards. Never buy if, no, I said that right. Never buy if left is greater than right. So here left is greater than right, so I don't buy. My right can keep moving up, and so I'll get a quote unquote right max of 0. Compare right max and left max, or stagger pointer movement. I think I want to stagger the pointer movement. So here I got 7 to 1. I will check 7 to 1. I will check 4 to 6. And I'm only going to pick one of those movements. So if I check 7 to 1, I'm going to get a gain of 6. If I check 4 to 6, I'm going to get a gain of 2. So then I pick the gain of 6. Now I'm 1 and 4. 1 to 5 is a big L. 4 to 6 is a small dub, so I'll make that move. 1 to 5 L, 6 to 3 L, so I get a lock condition, and so 1 and 6, right? So that is a dub. Okay, prefer staggered. Now let me check edge cases and make up my own to make sure that like this is kind of like a robust strategy. So edge cases, what if it's an empty price set? So that's not going to be the case. So we're constrained to at least have one. But if that's still an edge case, what if it's a single price set? So then don't, like it doesn't matter. So, okay, edge case length is less than 2, return 0. Can we have negative prices? Nope. I think we're pretty good. Are there any other edge cases? Not that I'm thinking of. This looks pretty good to me. All right, so let's start coding. Boop, 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 Nickelodeon. So I'll just turn this pseudocode right into real code. So return. I'm returning the profit amount, right? Not any indices. Yeah, so I'll just return 0. So if prices.length is less than 2, Guard clause in the house. What up? What up? And we will eventually return max profit. We can recycle this, initialize it to 0, and then we can that's not really helpful. Whatever. Should I nest it? I don't like nesting it. I'm going to keep it flat. Like, technically, I could nest it all inside that guard, but I'm just going to let the guard clause do its thing. And sure, why not? I mean, it doesn't really buy me anything that I'm returning max profit versus the constant 0. By the way, let me do the O of n space-time on this proposed solution. So the time is O of n. So it's a max 2 pass. No, it's a 1 pass. It's a 1 pass solution. Memory is constant because I'm just using pointers. So this is basically optimal as fuck, basically. You're not going to beat, it's theoretically impossible in a case with this price array. It's theoretically impossible to beat 1 pass with constant time. Or sorry, yeah, no, that's right. 1 pass with constant space. Theoretically impossible to beat that. Okay, cool. Let's initialize some pointers. So let left equals 0, let right equal prices.length. So if I have, that needs to be -1, yeah? If I have a single item, length will be 1, but the index, max index will be 0. Cool, so it's -1. While certainly while left, yeah, while left is less than right, let's think about if they're equal. I don't need to check if they're equal. If they're ever equal, then I can return 0. So we've pre-initialized max profit to be 0. So it will either be 0 or some larger number. So we can dismiss the case. So we only need to actually consider cases where left is less than right. Now, when I say left is less than right, we're speaking in terms of the index. Let's think about the value. Never buy if left value is greater than right value. Okay. So I want to distinguish between the left value and the left index. So I'm going to call this left IDX, right IDX. Okay, and so then we will say const left value is prices left IDX. Const right value is prices right IDX. Here we will do the thing and then modify indices. Okay, so this comparison, we want to say like const cur profit. I don't even need the cur profit. Yeah, why not? We'll break it in 2 lines. You could do that in 1 line, but I'll do it in 2. Cur profit and then set the like all-time high, basically. So the cur profit is left value minus right value. And then max profit equals math.max of max profit and cur profit, right? So we got the max profit. Now, how do we modify the indices? We check increment left, check decrement right, pick whichever is better, or eject if locked. Okay. To do bad ejection may be possible if a local maximum is found but not a global. All right, so we need to be careful about that, but let's put that edge case to the side and implement this pseudocode. So check increment left. I'll make a helper. We'll call this const get shifted, or like get future profit. Let's just say get profit. Can I just say that? Get profit equals prices left, right? So that will be left value minus right value, which is, yeah. Left value is, this is going to be an index thing, yeah? So prices left minus prices right. So const if shifted left equals get profit prices left right. Now this will be left index, right index, left index, right index. Sorry, IDX. And then what we do here, if we shift left, we want to left index plus 1, right? And then right index minus 1 would be the, if we shift right. I don't like this nomenclature, and it is worth pointing out in an interview, like, hey, let's get terminology correct. So I'm going to say if modify left. So I'm going to say if increment left and if decrement right. And I'm actually going to say with instead of if. So with is more idiomatic in JavaScript world. I just copy paste now. I'm selling it on eBay. Lit. I don't know what you're saying. Okay. Cool. So with increment left, with decrement right. We could solve for this by just proceeding through local maximum. So maybe we just never eject, right? Pick whichever is better, or I'm going to say increment left in a tie. Modify indices, pick better amongst two options, or increment left arbitrarily in a tie. Such a typical thing for a Trump to do. Shush. All right, so we're gonna just like bypass the bad ejection possibility because we're just never gonna eject. The downside is that we are slowing down our average case. But the good news is that it's still a max 1 pass. So like, who cares? Like, it's still really fast. Okay, so if with decrement right is greater than with increment left, then we do the decrement. Else, we are going to do the increment. This will be left index plus plus, right index minus minus. Okay, so I think we're getting close to ready to run it. Let's review where we're at. Started off at 0, check the edge case. From left, let's buy as low as possible. From right, sell high. Buy low, sell high. Naive pointer. Right pointer moves left if I minus 1 is higher, but left, check. So we implemented this naive pointer, and the comment is a little confusing. I think the code speaks for itself better than the comment does. Left check is lower or equal. Interesting, interesting. I didn't quite do that. So this will allow a lock. This is like an allowing a lock, and I did not allow the lock. Maybe keep a cache of current max profit. No, we don't need to cache it. Never buy if left value is greater than right value. Yeah, I have this max profit clause expression, which is taking care of that. Prefer stagger, we did that. Compare right max and left max or stagger, we chose to stagger. From left, buy as low as possible. From right, sell high. I don't know. Is that a helpful comment? Is that a helpful comment? I don't think so. Cool. Let's run the code. Let's check this. While the left index is less than the right index, so we have a minimum case of 2 length. So yeah, this works in the case of 2 length. Initialize to 0, initialize to 1. 0 is less than 1. Pick the first one, pick the second one, compute the profit. And then it's either 0 or the current profit. Cool. Is this node? Sure. I mean, basically, yeah. This is JavaScript, so this function would run on the client side or on the server side. If you ran it on the server, yes, you would run in Node. Okay, cool. So this was wrong, so let's figure out why it's wrong. So I output 6, we're expecting 5. We're expecting the 1 and the 6. The 1 and the 6. Did I get this backwards so it rested on the 7 and the 1? Okay, let's see. We're going to start off at 0. We're going to start off with the 7 and the 4. Left index is less than right index. Yes, it is. Left value is 7. Right value is 4. 7 minus 4. Current profit is 3. Yep, that's backwards. So my current profit is wrong. So I said if you buy at 7 and sell at 4, you made a profit of 3. So that is backwards. Let's try it like this. So now I said 0. Right value minus left value. So 4 minus 7, that's negative 3. Good, so current profit is negative 3, so then the max between 0 and negative 3 is 0, so we retain 0. Now we say with increment left, I consider incrementing the 7. So I increment the 7. With increment left ought to get me 1 and 4. Let's see. Oh, I need to switch it here as well. Yep, I need to fix my helper function. Okay. Okay, that fixed it. Should be right minus left since you buy on right. Mohi for the win. Mohi's got it down. All right, so the interviewer is like, hey, is there a way we can improve this? And the answer is yes and no. It's at an optimal time and space complexity, but as we saw, we have the current profit computation logic in two places, such that I fix it in one place and it's still not fixed in both places. So more optimal would be to reuse my get profit helper. Also use it here, and I would not have run into that second need to debug, right? And I can also reduce my lines of code. So I can just get profit here, prices, left IDX, right IDX. So let's make sure that didn't wreck us. Can you move the cam and zoom in a little bit? I really can't, I'm limited, but if you go to YouTube or Twitch, I think I'm also streaming on Twitter, so it's still John Vandeveer, find me over there. I can move it kind of like left and right, but I can't really, let's see, I can zoom in, but is that really helping you? I can't zoom out though. Like this is the most I can zoom out. Okay, so simplified, reuse this helper one more time and we're still good. I think in the case where it's a tie, guessing to just move left might cause an L. So Mohi, I don't think it's a guess. It's an arbitrary rule. So if we're 5 and 5, like the current index is 5 and the next index is 5, then moving up will never cause a profit loss. And what it could do is you could uncover a profit gain, obviously not moving from 5 to 5, but on the right side of the second 5, there could be a profit gain. So we need to explore that space. Anyway, so I'm going to go for it. Let's see, you could be right, but I'm still pretty confident. All right, so this was, let's see, wrong answer. Why? Is this from today? This is today, right? So here. So 1 and 7. Let's see, the output is 9. That means I went, what, 2 and 11? Yeah, and 1 and 11 is better. Okay, so I guess I can't stagger the checks. I think I need to check all the way left and all the way right. Dang, that's going to really increase the time complexity if I do that. It says I solved this before in TypeScript. And it looks like Mohi's exactly right. Okay, so why did I move from 1 to 2? Why did I move from 1 to 2? So that should have made the width increment left was smarter than the width decrement right, is the way that would have happened. So we got 1 and 7. That's a 6. If I go from 7 to 4, that's a loss. Yeah. If I go to 1 to 2, it's still a loss, but it's less of a loss. Okay. So this is because I decided not to ever lock. So let's decide to lock. Okay, so we come back over here. We come back over here. Where am I at? Here I say with, like, basically I need to add some complexity here. So I'm never locking. Basically I need to lock with decrement right. Hold on, let's look at this one more time. I really don't want to have to do n squared. That would be terrible. I guess I can accumulate like the minimum buy price and the maximum sell price. I might need to do that. Okay, let me add a comment. To do maybe accumulate minimum by and maximum sell. This would really suck if I have to like sort the array and all that. So let's see. Locking that 1 in is pretty easy. The problem is, how do I get from 7 to 11? Because if I add locks on both sides, I just never go, like I'll return 1 and 7. Like I'll return 6. So I'll just never get there. So another solution I can do is like, hey, at 1, test all the things. Nope, that's bad. At 2, test all the things. Because then we get into n squared. That's really, really bad. I could do a pass through the array, and at every index of the array, I could have the minimum by. Maybe that's what I need to do. At every index of the array, let's see. So to do maybe accumulate minimum by and minimum sell. I'm not sure if this is the same thing or different. Maybe, maybe single pass identify min by at every index. So then I could get a 2-pass solution, right? Find the minimum by, find the maximum sell, and compute the differences, and I would have a 2-pass solution. So I think that's going to work. Okay. So the naive was a 1-pass solution, but it failed. Okay. Let me copy all this because I'm about to wreck it, I think. Bam. All right, cool. So we're going to comment all this. Bam. The get profit thing is still good. Okay. So secondary solution, 2-pass O of n solution. Step 1, single pass identify min by at every index. Step 2, single pass identify max sell plus potential profit at every index while caching max profit. Okay. Mohi has a really good test case. Let's see, since it goes up and down. Thanks. Let's do that one. I will write it down. A la Mohi. 3, 6, 1, 8. 3, 6, 1, 8. 1. 100. I like that. Cool. Cool. So let's implement this. And it's basically still pretty optimal, but it's no longer a 1-pass solution, but it has the same asymptotic complexity. Okay, so we start at 0. We start at the max. That's great. While left is less than the max, that still holds true. We get the profit, compute the max profit of the current profit. Okay, this is where things get shaky. This is where things get shaky. Ooh, no, this is not a pointer pattern at all anymore. Okay, let me comment this. I'm not sure we are doing a pointer pattern at all anymore. I already have it backed up top, so I'm just going to obliterate it. So here we have const min buys equals prices dot map. I'm just going to do it like this. So this will be price min buys. Can I just do a map? I think I would need like a reducer. This will be like curmen. Negative infinity. Are we really doing this? Negative infinity. Curmin is negative infinity, and curmin buys is an empty array. So here we have the accumulator, and then we have cur price. Okay. I'm going to break that line. Frankly, the whole reducer is already looking ugly, so I might not want to use a reducer. Okay. So the accumulator is accumulator dot cur. Let's see, this will be 2 lines. So accumulator dot cur min equals math dot min. If I want the min price, I need to have a limiting case of positive infinity, not negative infinity. So act dot cur min. It's going to be the minimum of that or the cur price, because you can buy at the current price, or let's see, the minimum buy at every index. You can buy at the current price or whatever was previously the minimum. And so this will snap to the first available price because it's guaranteed to be lower than infinity. All right, cool. So we got the current minimum price. And then we want the cur minimum buys. ACC dot cur min buys. Call this min buys, and then we will destructure that. I'm going to take min buys. This is going to return an object, but we'll destructure min buys out of it. It's going to equal acc dot min buys dot push the cur min, and then return acc. Cool. That's a really ugly reducer. We might come back and change that. Also, I don't really know if I give a shit. Okay, so that is the minimum buys. Now we need to know the maximum sells and the potential profit. Okay. Let me just run this to make sure that it doesn't error out. Because I kind of want to repeat the pattern, but I don't want to repeat it if it's going to error out. Yeah, runtime error. Unexpected token, min buys. Oh. Minbuys.push is not a function. Here is minbuys. Yeah, that's weird. It's an array. Accumulator. Right. It's by reference. Cool. I was just testing that we didn't error. So we fixed that up, and now I feel more comfortable copying it, even though it's ugly, but fine. So you have minbuys, and then this is going to be max profit. We'll call this, we'll call it max profit. Here we'll do 0. Yep, clean that up like so. Max profit is we're going to reduce off of prices. So here's the current price. Here's the accumulator. We'll have the cur min buy equals min buys. So we also want the index here. Cur min buys IDX. Const cur max sell, and then const cur max profit. Cur max sell minus cur min buy. So here in the accumulator, we no longer want the cur min, we want the cur max sell, which is going to default to -infinity. And then the max sells. This feels really pretty useless. This array feels pretty useless to do. Maybe don't need max sells. Okay. So here is the accumulator. Cur max sell is math.max of cur price or acc.max cur max sell. We want this to be persisted by reference. So acc.cur max sell is math.max that, right? And this goes right here. Cool. Cur max profit. Am I using this anywhere? Cool. So cur max sell max profit is 0. I think this is the thing I really want to accumulate. So here's cur max profit, and then acc.max profit equals math.max max profit or the cur max profit. Cool, so we get the minimum buy, max sell, max profit. What is this guy doing here? Cur min, cur min. I just really feel like I don't need this. And then I don't end up using that, do I? All right, let's see if this crashes. Wrong answer, output 6, expected 5. Why would this be? Let me console.log men_buys, and we'll sanity check that. So men_buys 7, 1, 1. Yeah, that looks good. Did I do this? Did I do the stupid left and right backwards again? So men_buys, you buy at 7. Men_buys, men_buy. Max sell minus men_buy. How would this ever turn out to be 6? Cur max profit. So cur max sell would have to be 7. Yeah, because I need to roll backwards this time. Let's see if I can just cheat like this. What? All right, let me quit being lazy and spell out my actual max cells. This is going to end up being a 3 pass, but it's like more for debugging purposes than due to technical necessity. I should be able to do this in 2 passes, but I want to debug it more cleanly. So here we'll do max cells. Let me skip the max profit thing. Okay. Cur max sell. The largest of the accumulated maximum sell and the current price. Yep. Cur minimum buy, I don't need that. Okay. So at index 1, or at index 0, I could sell it for 7. Index 1 for 1. Yeah, this is what's wrong. So let's see that reverse thing. Kind of feels like the reverse thing didn't work. So I should start with 4. So I should get 4, 6, bunch of 6s, and then a 7. So let's see. I should get 4, 6, bunch of 6s, and a 7. Yeah, it's like empty. That will be a problem. That'll do it. So max cells dot push cur max cell. Run this. You maintain the max buy as 7. Bad if true. So 4, bunch of 6s, and a 7. That is what I expect. So I could do a 3rd step here, but like I shouldn't have to, right? Oh shit, maybe I do. Maybe that was the issue, is that I was trying to do it all at once, but I need to get the whole array. So at 4, So here at the 0 index, I know that I can sell it at 4 and I can buy it at 7. Like, I know that's a bad idea. Then I know that I can sell at 6, buy at 1, sell at 6, buy at 1. And eventually I can sell at 7, buy at 1, but that's a lie. The last one is a lie. So that's where the issue is coming from, is like, at the very last index, yeah, at the very last index, I thought I could buy it for 1 and sell it for 7, which is not true. So I should have a 4 here. Max sell it. No, that should be. Max sell is a 7. I can never sell it at 7. Why are you saying you can sell it at 7? I think I just need a special case for the 0 index. Does that sound right? 4. Sell at 4, sell at 6. At 6, the min buy is 1. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right, okay. So off by 1, so index of 5. The min buy is 1. Yeah. Why am I getting 7 here? Max sells array doesn't help. Oh, yeah? Okay. Max sells array doesn't help. Do I want to still reverse this? So here, what if I never reversed it? Or what if I never did max sells? Then it would be 4. So we got buy 7, sell 7, buy 1, sell 1, buy 1, sell 5. Okay, that would pass this check. Let's do the a la Mohi test. So 3, 7, boo. Oh, that would be a very different scenario. Your input 715. Okay, now it's your input 3618. 36181 100. Okay, so min buys would be, I'll write it out. Min buys would be 3, 3, 3, 1, 1, 1, 1. Yeah. Min sells, like, we're gonna, like, don't do this. So we're just gonna compare against the thing itself. So here, 0, I could get 3, 0, 7, 0, 99. Looks kind of like it works, right? You pick the 1 and the 100. Okay, maybe it works. Cool. So let's try commenting this. Bam. Const call it flipped equals prices.reverse. Do the basic for loop. I equals 0, I less than flipped, I plus plus, const cur price equals prices I. This would be const cur profit equals, we just do max profit. Max profit equals math.max, max profit, or cur price minus min buy. Min buys at I, and then here again we let max profit equals 0. I think that's about it. Okay. Did I do the darn left? So flipped, we got 4. I'm just going to do diffs, like my brain is melting. So let's do diffs dot push cur price min buys of I. And I just want to log diffs. Diffs is diffs is an empty array. Diffs dot push. Why'd that push fail? Oh, also this should be flipped. Is that the whole problem? Min buys. Let me just put fucking current price on here. It's like, what is going on with diffs over here? Diffs. Is not getting anything. Oh, geez. Dot length. There we go. Okay, so 4, 6, 3, 5, 1, 7. This last guy. What's going on here? Because I shouldn't be flipping it. Okay, cool. You're dumb. Great, thanks. Okay. All right. So that flipping thing is happening by ref. Let's get rid of this. Yeah, I think that's what we're going for, right? One more time, make sure I didn't break anything. Submit it. Okay, so that worked. It's pretty slow, faster than 23% of JavaScript submissions. I think it's slow because of this reduce. So let me see. Let me fix that real quick. So let cur min by equal min buys. We still want min buys. We'll initialize this one at 1 because we already preset the cur min buy to prices 0. And min buys, we will put that on there. I less than prices dot length. This is a lot. This is actually more readable, I think. All right, let's see if that still works. Okay, so that's better. Min by can be int being updated in your loop for line 60, so now it's one loop. Mohi is pro, y'all. All right, we shaved off some time there. So we got it down to 104 milliseconds. But it's still a 2 pass. Bam. Comment this one, and then here we'll put a note. Mohi totally helped me cheat for this optimization. I'd like to think I might have thought of that, but I'm kind of brain dead right now, so maybe I wouldn't have. Cool, so we want to collapse these two loops, basically. So the minimum buy, we just update it on the fly right here. Cur min buy. Bam. So that's cur min buy. And then I can just do this. Cur price minus cur min buy. Cur price, that's the cur price. Throw you up here, cur price. So I don't need that. So the current min buy starts at 0. Yeah, we can actually ignore the I equals 0 case because that would be a 0 profit anyway. So let I equal 1 through prices length cur min buy is either like from the prior index or it's the current price, whatever is lower. Bam, bam, bam. All right, so I think that does it. Bam, I think we got it even faster than ever. Faster than ever. Faster than 97% of JavaScript. Mohi is your JavaScript god. Everyone say thank you, Mohi. No, that's great. I love that. All right, cool. I think I'm basically brain dead. Can we check a duplicate? Duplicates are like easy mode. We can check a duplicate, right? Let's find a fucking duplicate. Fuck duplicates. Given nums, return true if any value appears twice. This is like super easy. You just convert it to a map. This is almost like cheating because I just know the answer. Okay. Const scene equals if return true. If scene cur and then else scene cur equals 1 for const cur of nums. All right, so for cur of nums, if you have seen it, return true. Otherwise, like, all right, let's test that. All right, fuck your duplicates. I think that's the fastest Leetcode I've ever solved. Now do it with a set. Yeah, but actually set is slower because you can't break out early. Let's do it with a set though, just for kicks. So const unique set equals set of nums. Is it from? I forget. So if cur in unique set, like I think it's like unique set dot contains. I don't know what the method name is. Return true. Actually, you could just return. Yeah. This is probably an error. Oh, new. Ba-da-da-da-da. Yeah, it's not. Check if number and check if value and set. I think it's has. Before I Google that, I think it's has. Okay, so that's it. But you see the runtime is slower. Ew, wrong answer. What happened? 1, 2, 3, 4. Shit, that was dumb. Because I don't want to know if it has it. I want to know if it has it twice. I should be able to compare the length. This could be faster, maybe. No, I don't think it is. So return nums.length is exactly equal to unique set.length. It might be like dot count or something. So the why is it saying the length is exactly equal? 1, 2, 3, 1. Your Boolean is flipped, by the way. Like, okay, hold on. Let's. So line 10 is flipped. Is that what you're saying? I don't see how it could be flipped. Okay, so if the length is equal, because if the length is equal, they're all unique, right? If the length is equal, they're all unique. So then it doesn't contain a duplicate. I got you. Yep. Thank you. Thank you. Thank you. Okay, so 94 milliseconds. Let's see. FML output was true. 1, 2, 3, 4. They're all unique. Expected false. I think I'm tired. So the lengths are equal. Hey, what's up, Vincent? Does set even have a length? Let me check this. JavaScript set length. It's gonna be so stupid. Okay, it's size. Look at this shit. It's doing some shit like length is not a property, therefore it can't be equal kind of shit. Is size a method or a property? Let's see. It's just a property. I'm asleep. All right, dope. See ya. Have fun sleeping. Shoo. All right, let's see if this works. So that worked. Ooh, it was actually faster. Look at that. I'm pretty surprised. And it's not obvious that it was lower memory, but it was faster. Cool. So let me, I'm going to keep them both, just like for my own reference. Let me make sure that this other one is still valid. Wow, the set is faster. There must be some like behind the scenes magic going on to make that faster. Because you would think that this could break out early. It would short circuit, so you would have less actual operations going on. I guess I don't even need this guy, huh? Okay. Thanks for the tip. Bam, bam, bam. I just want to see it go under 84. Oh, bullshit. The same code ran 92 milliseconds. The same code ran in 92 milliseconds. So it's got like some variance on it. Whatever. I'm happy. We got it. All right, we crushed 3 tonight. They were all easies, but I'm still happy about it. Thanks for tuning in. We're going to get through the blind 75 here in the next couple weeks. I've never done the blind 75 all the way through, but I think it's more than easies. It shouldn't just be easies, right? I'm also doing Algo Expert. I can't record those. It's against the terms of service, but I'm going to be doing that. So thanks for tuning in. See you later.